Hello, I'm Gwyn Nelson, the Programme Manager at the new Wales Coastal Monitoring Centre. I'd like to start with a thank you to Toby and the team at CHERISH for your support and guidance so far. We have a common interest, climate change and the coastline, and there's a huge amount of crossover between us, which means we face the same challenges. This provides the incentive for us to share ideas and hopefully will lead to collaborative opportunities going forward. We're a team of two. Will and I started full-time in 2019. We've managed to leverage multiple funding streams to unlock the placements shown on the left. The WCMC are 100% funded by the Welsh Government from the Flood and Coastal Erosion Risk Management Budget, or FCERM. We've just entered our second phase of funding, hopefully securing us for the next 5 years until 2026. We report to a consortium and an advisory panel. Our delivery team includes local authority surveyors and contractors. Data is kindly hosted by the National Network Regional Coastal Monitoring Programme in England. And let's not forget the most important item missing off this organogram. Of course, we're here to serve the people of Wales, guided by our aim, which is to develop a national approach to collecting the evidence base to support FCERM decisions. So what do? Simply put, we manage the beach surveying contractors, increasing data quality and decreasing survey costs. We also help to train maritime local authority survey teams and make all the data available. We're effectively coastal data aggregators. Challenges. So 60% of Wales's population live and or work on the coast. We have diverse geology, some of the highest tides in the world, and exposure to storms of an ever-increasing intensity and frequency, plus a growing public awareness of climate change. And of course, coastal processes aren't restricted by political boundaries. The historic local approach needed to be scaled up nationally. How do we achieve a national approach with a small team and limited budget? This is our risk-based methodology, which shows how we rapidly scored the Welsh coastline using previously completed shoreline management plans as a basis. The shoreline management plans broke the coastline into units. Based on work done in England, we scored each policy unit for risk. We used existing policies, future recommended policies. For asset risk, we did a property and infrastructure count of those at risk of coastal flood and erosion, represented by the blue and brown surfaces here. The beach behaviour, in the absence of years of consistent pan-Wales data, we used a study called Future Coast, which provided beach width data and predicted shoreline evolution. This is a pan-Wales view of our risk-scored policy units, or RBM. The topography of Wales is shown, giving an indication of low-lying land. The cloud shadow is actually a population heat map. The white coastline is low risk, and dark red is high risk. Take note on the borders with England in the north and the south, here and here, both being high-risk estuarine environments with high populations and low-lying land. In contrast to, say, Pembrokeshire, with a low population and fairly high stable cliffs. We also worked on our topographic specification, which ensures methods, accuracy, data, processing and deliverables are the same across Wales and integrate into the neighbouring English data sets. We encourage any coastal data collected by risk management authorities or consultants to use the specification. Our programme, shown on the map on the left, is based on the RBM and locations we can access. It shows our survey units, colour-coded by survey type and frequency. We used a cost model, iteratively applying it to our budget to determine how much we can survey. For the next 12 months, we'll be focusing on the topographic survey on the locations shown by the red lines. Notice the borders with England aren't monitored. The RBM previously identified these as high-risk areas. We can't access them with terrestrial survey methods, and our budget doesn't extend to aerial methods, so we currently have a gap. This pushed us to collaborative and investigative survey trials to help identify the most appropriate coastal survey techniques in Wales. Firstly, this autonomous bathymetric survey vessel was used in collaboration with the Maritime Coast Guard Agency for an inshore section off West Wales, including Fishguard Harbour seabed, as shown here. We investigated point cloud data with photogrammetry fixed wing drones, but didn't have much luck. Considering the restricted number of tidal windows for the required mean low water springs datum, our trial lost 50% of the windows to wind, a day to fog, and a day to a hang glider. Although the final data set proved a reasonable accuracy on the structures, 80% of our beach was flat and wet sand, which is beyond the capability of photogrammetry. If anyone has overcome this problem, please let us know. Adair and Worthing Council kindly came up and surveyed Aberavon for us with their mobile laser scanning ATV rig and provided a highly accurate 8-kilometre stretch of beach from one tidal window. Very impressive, though not a cheap setup and still can't access muddy areas. The Severn Partnership also trialled their Pegasus mobile laser scanner on a quad for us. And here we can see unmanned survey solutions. We successfully trialled their latest unmanned surface vessel with multi-beam and mobile laser scanner on the Conway Bridges and Fisherman's Berth in North Wales. Finally, as we have a small budget, this requires us to be a little bit more innovative. We learned that the British Geological Survey had the latest mobile laser scanner like a backpack, and they kindly agreed to a trial with our e-trike with snow tires. The bike provides 20 miles per hour for 2 hours and has interchangeable batteries. It's cheaper than an ATV, easier to store, manage, maintain, and has lower environmental impact. On the left is the resultant colorized point cloud of Tenby North Beach. We collected highly accurate data during Storm Kira. Varying weather vulnerability of the equipment left us very keen to know the potential operational performance numbers, because weather is the biggest risk to our surveys and our budget. We found funding with GEOM at Aberystwyth University to build a software tool which could assess historic weather and tides. Based on the limitations of differing survey equipment, estimate the number of operational hours we'd expect in an average year. For example, drone would require the alignment of mean low water springs, wind speed below a certain threshold, daylight hours, no rain, and no fog. This tool will also support our decisions when buying equipment. We wanted the tool to be freely available and beneficial to anyone with a tidal data set who might want to understand their location-specific equipment weather risk. It also works for planning bathymetric surveys. It uses the free European Copernicus reanalysis meteorological archive, which can provide any location on Earth for the last 40 years. So, which coastal survey techniques are most challenged for operational hours in, say, Llandudno, North Wales? Vessel-based surveys are no surprises here with the lowest number of hours. There's a close tie between our wind and rain vulnerable techniques. It's Wales after all. UAV LiDAR wins over topo on foot and ATV because it can access night tides. We don't send people out on the beaches in the dark. But how much time would we get if we weren't vulnerable to weather and daylight, such as an unmanned terrestrial vehicle or UTV? These currently aren't on the market. Finally, we put a lot of scientific emphasis on achieving the mean low water springs datum to inform the sediment budget depth of closure. So are we focusing too much on the meteorological component? What if we relax the mean low water springs datum by just 20 centimeters, such as wearing waders when doing top on foot? It's quite a significant increase in operational hours. If you think this tool could be of use to you, we aim to package it up for download as soon as possible on our website. Some of the most progressive technological breakthroughs have happened by accident, such as the microwave, or through the cross-pollination of ideas like the MRI scanner. Inspired by these inventions, we annually review the most disruptive technology of the last year. In 2020, AI deep learning from image analysis was listed in the top 10. GEOM have recently started the next project for us, which is to look at using CNN algorithms as a tool to potentially derive sea state characteristics from satellite radar data. As satellites are permanently recording the sea surface and visit every location on Earth at regular intervals, we're hopeful it can unlock historic measurements at any marine location on Earth where readings don't currently exist. As seen on the graph here, by tweaking our tidal datum slightly, we can achieve significantly more operational hours. We're also starting an investigation with Bath University into the importance of Mean Water Springs datum for FSERM data. Learning about the equipment operational hours, we wondered if drone technologies such as miniaturized cheap RTK receivers and a Raspberry Pi could be added to a remote control car or UTV. So this is Crank, Welsh for crab, funded through KES2. We're about a third of the way through a research master's with Aberystwyth University robotics team. The aim is to produce a Rover, provide the software and a manual, free to all with the shopping list of off-the-shelf components for £1,000. The current iteration uses a point cloud stereo camera, a rock crawler chassis, which has interchangeable tracks for navigation on estuarine environments, a £400 drone RTK receiver. The purchase costs are currently estimated at £1,500 with some 3D printed parts and a little soldering required. It's early days, but in the right environment, it could be a supportive tool to help increase the productivity of surveyors on our baseline surveys with multiple rovers deployed. Survey at night, increasing tidal hours with its active stereo camera offering point cloud data. Increase safety, removing people from the water's edge. Access some of our high-risk, inaccessible mudflats. Reduce some ATV need and therefore environmental impact, especially at nature-designated protected areas. It has the potential for being adapted to larger vehicles, and it has spare ports for additional sensors. It could be based permanently in situ in a charge dock and go out daily autonomously. Multiple units could also mother duck to an ATV, giving a greater swath. Or it could just be used as a ground control point for drones with a checkered hat on top. Send it out across dodgy terrain as it records RTK all day for you. Examples of other collaborations include for the people of Wales. On the left, you can see SWEEP's coastal flood forecast model. CMAR at Plymouth University kindly found funding to extend their forecast model and include our beach profiles. This allows the people of South Wales at coastal flood risk to be prepared and sign up to localized forecasts. We've also been developing a 10-lesson program on coasts and climate change with Barry Island Primary School under the new national curriculum, 2022. I was blown away when I saw the kids were using virtual reality headsets in class. So we've collaborated with multiple international universities to build annotated 360 coastal environments around the globe for the kids to dive into. These can all be found on our website. It's been a busy few years, which we've really enjoyed. Operationally, we need to complete our data finalizing and analysis deliverables, which will be informed by our stakeholder assessment. This has just been started. Then we'll be able to set up our reporting systems. In terms of improvements, we're looking towards automation, such as robots and software, and also the potential in drone LiDAR, which is developing rapidly. We will also seek more opportunities to engage and inform the people of Wales about the risks and actions needed to mitigate the impacts of coastal-related climate change. Being a small nation allows us to be nimble in our approach so that we can be open to new developments and change direction quickly to maximize their impact for the people of Wales. Thank you all for your time.